Let's see. Now, as announced, a quick glimpse. So here once again, the diagram from before. On the left, the diagram shows the sources from where the disjoint data is pulled into the core system via an extract, transform, load process. The core of the infrastructure in the middle is based on the so-called pub/sub messaging framework Apache Kafka. Consuming components are on the right side. Here we have Cantaloupe as a IIIF image server at the top that delivers images, a search engine, and a MongoDB database, which is a data lake that forms the backend for the APIs like a REST API and IIIF APIs that complement the image server. Let's focus now on the core of all of this, Apache Kafka. Kafka was invented by LinkedIn to handle the massive data flows generated by the social network. And it has been made open source in 2011. In 2013, it has been accepted as Apache Foundation project. And since it is named Apache Kafka. Technically, Kafka is a distributed event store and stream processing platform. It promises real-time processing of messages with a latency small as 2 milliseconds. It scales to trillions of messages per day and petabytes of data. It is major, robust, and has a vast ecosystem. Complementing tools have grown around it. This listing is a lot of names. This listing of a lot of the tool names is far from being complete. And it is being used by many enterprises worldwide and became globally too relevant to suddenly disappear. It is a framework that allows you to build a wide variety of conceivable infrastructures for a wide variety of scenarios. Because it is a technology, because it is a base technology, institutions must actually develop their infrastructure with it and around it. It is not an out-of-the-box application that fits many needs. Even if Kafka is fast, scalable, flexible, and so on, it also brings a lot of complexity. So we asked ourselves, is it too heavy? Is it worth dealing with this complexity, with this beast? Are there alternatives? Of course, there are other messaging pipelines, like, for example, RabbitMQ or data warehouses, a completely different approach, less ideal for us. But finally, we found that Kafka was a very good and sensible choice for the ZKM. What are the benefits of carrying the extra load that is imposed by the complexity of Kafka over other solutions? For us, the main benefit of using Kafka are: it can connect to almost any data source and sync. It's possible to integrate data from distant sources. It has a built-in data processing capabilities. You can join message streams similar to the SQL joins known from relational databases. It can consistently and reliably handle updates and deletions in the data sources. You can configure the message retention time and strategies very flexibly, and you can handle also very large messages up to gigabytes. To understand this better, we now take a look at the use case of Herbert W. Franke, and we will focus on the task of making the manuscript searchable. We want to be able to search the metadata as well as the text of the manuscripts that have been OCR'd. On one side, we have the sources, two databases with archive records and persons, each with multiple tables. We also have a file store with PDFs that contains the OCR'd text. The database records have relations to other data. For example, archive media refers to PDF files, records to persons. On the other side is the search engine, the thing that needs to receive this information. Now we need to bring all the information that constitutes a full archive record together as one big object and feed it into the search engine. The Kafka Streams API is an excellent tool to handle this situation reliably. The system managing the archive metadata has an SQL API. The persons can be fetched via a REST API. Kafka Connect already has connectors to pull data from these APIs. The two adapters now poll for data changes in the sources and publish to new records of each of the database tables as a message into the according Kafka topics. To get the text from the PDF files into Kafka, an extractor has been created that extracts the free text and that pushes it into another Kafka topic. Now we need to combine all these messages from these topics. For that we can use the Kafka Streams API, as said, in order to join it into one big data record object that contains now everything, also the persons and the free text. And this can now be fetched again by another connector that pushes it into the search engine. There's much more to say about the details of the architectural scheme, but that's for another time.